So now that we know we have 4 degree of freedom mechanism, or we have a 4-bar linkage, which has 1 degree of freedom as a mechanism, we've seen that they can have different names of the links, but we want to start to classify them because they can be very applicable to many scenarios, but based off of their geometry, they're going to have different behaviors. So we're going to learn more about the 4-bar linkage and specifically the Grashof condition. So let's go ahead and we're going to draw a 4-bar linkage, and we're not going to worry about if any of them are a crank or a rocker or a coupler or which is ground. We're just going to look at their lengths, and we're going to name these lengths S, L, P, and Q. So S stands for the length of the shortest link, L is the longest link, and P and Q are our middle children, which I say because Paul is my brother, he's the middle child of mine, but they're just the names that we gave the length of the remaining links. So one is named L, one is named P, one is named Q. It does not matter which is which, because we're going to use these 4 numbers to classify our linkages. And based off of the condition, we're going to have a type of the linkage that they are. So if S and L, so the shortest and longest added together, are smaller than the 2 remaining links, P and Q, then we have a Grashof linkage. If they are greater, we will have a non-Grashof linkage. And if they're equal, we still have a Grashof linkage, but we're going to highlight them as a special case. And you might be wondering, what on earth is a Grashof linkage? Well, if a linkage is Grashof, then that means that at least one of the links can make a full rotation or a full revolution. So it can travel an entire circle around its pin joint. Sometimes there'll be more. It's usually going to be the shortest link, but those are our Grashof links. Now, if we have a non-Grashof link, none of the links can make a full revolution. And that's going to be something that we'll have to work around it if we're trying to use a Grashof linkages. We're going to get to that in a future class. Finally, we have our special case, which at least one link can make a full revolution, but we have to be careful because there can be some repercussions. We're going to talk about the different classes and different example of all these in the future, but for now, if we're just considering if a linkage is Grashof versus non-Grashof, then that is the way that we can find it. We take the lengths. If the shortest and longest links are both larger than the 2 remaining links, we have a non-Grashof linkage. If they're smaller, we have a Grashof. Also, in the example I drew, the longest and shortest were right next to each other. That's not always going to be the case or a requirement. So let's go ahead and draw some more. If we have S, Q, L, P, and I guess those are our options because P and Q are arbitrarily chosen, but if we have them S and L next to each other and P and Q here, then that's going to have different classes or different classes of our linkages. We will talk more about that in the future. For now, we're just determining, is it Grashof, is it non-Grashof, or is it a special case? So that'll be it.